So on page 9, we're going to take a look at ways that we can represent the patterns that we see in sequences. That's going to be our big idea for today. So you guys stay on page 9, but I'm going to flip back in our packet. Just as a sort of a reminder, refresher, what we're looking at, what we've looked at so far in this unit is sort of patterns that I can pick out in sequences. So we have some examples where we've been given a rule or a pattern to use. We've had some examples where we found that pattern, and then we started talking about the different types of patterns that we could see. So we had 3 big categories. One of them was what we called geometric sequences, when I'm multiplying by the same number each time. That number I multiply by, we called our growth factor, or it also could be called your common ratio. But the idea was we wanted to know, what do I multiply by to get that next term? And if I know that rule, if I know that growth factor or common ratio, then I can continue to find those next terms in the sequence. Then yesterday, we looked at another type of sequence called an arithmetic sequence. And the idea here was that we were always adding something to get to the next term. So we're adding for an arithmetic sequence. And we called that number that we add, or if it was negative, we were really subtracting. We called that number our common difference. So if we knew that, we could figure out the next terms in our pattern. We could fill in missing terms for our sequence. So we had those 2 big categories. We talked about geometric when we're multiplying, arithmetic when we're adding or subtracting. And then the other big group was everything else, right? We had arithmetic, we had geometric, and then we had everything else, which we just said it's neither arithmetic nor geometric. And that was kind of where we left off yesterday, okay? Looking at these different sequences, determining if they were arithmetic or geometric or neither, and then being able to identify that pattern or that rule to find more terms in our sequence. For today, we're going to take a look at a more sort of formalized way to be able to write down what's called that formula, that pattern, okay? So we're going to start on page 9 with a visual pattern here. We've got some trees that we're looking at. How many trees are in my first term of my sequence? 3. How about the second term? 5. And the third term? 7. Okay. How many do you think would be in the next term? 9. What are we doing each time? We're adding 2. We're adding 2 trees each time. So here's another way that I could represent what's happening. Our n here tells us what number in the sequence we are. So our first term in the sequence, our first picture in the sequence, has 3 trees. Our second term in the sequence, we added 2, right, to that first term. And now we've got 5 trees for that second term in the sequence. For our third term in the sequence, we took 5 and we added 2 to get 7. So we're seeing some notation start to emerge here, right? For that second term, we took the first term and added 2. So for the third term, I would take the second term and add 2 to get 7, right? So for our fourth term in the sequence, I would take the one before, that third term, and add 2. So 7 plus 2 would give me 9. For the fifth term, I'm going to do the same thing. I'm going to take the last term, add 2, and I would get 11. Let's talk about the notation that we're seeing here. This is called a subscript. So when we see things written today and we've got something like a sub 2, I'm going to read that as a sub 2 because when I have things that are typed sort of below and small, that's called a subscript. If you think about exponents, right, or powers, we call them in math, exponents or powers. If I were to type this on a computer and I wanted that 5 to be in that sort of exponent spot, that would be called a superscript because it flies in the air like Superman. So this guy is a subscript, okay? So we refer to this as a sub 2 because I have 2 as my subscript. So what this is telling me is that I'm talking about the second term in my sequence. So I could say that a sub 2 is 5 because the second term in my sequence is 5. Does that make sense? So we're going to see this notation sort of throughout the rest of our unit. So it's important that we know what we're looking at. So remember that sub refers to where in the sequence I'm at, and it's equal to however many trees we have for this particular example. So I want you to notice for my sequence here, I'm always taking the previous term and adding 2. Now, what kind of sequence would this be? Arithmetic, geometric? These are arithmetic since we're adding 2 each time. Okay. So there's a way that we could represent this without having to always refer to the specific prior term each time. We're actually going to hop down to 3 and then we'll talk about number 2. If I wanted to write an equation or a formula, we could call it, to represent this arithmetic sequence, I could say that for any term in my sequence, so we'll call that a sub n for any term, okay, whichever one I wanted, I could take the one right before it. So if this is a sub n that I want, let's do the one right before it. That would be n minus 1. And then let's add 2. So this is a way that I can represent any term in my sequence. Any term is the term before it plus 2. So a sub n is the term I want, and n minus 1 is the previous term. We've talked a lot about arithmetic and geometric sequences already, how to continue that pattern, how to recognize which one I've got. So this is what we're going to focus on for today. How to be able to, once I know what type of sequence I have, once I know that pattern, how to be able to write what we call a recursive formula. Okay? So now let's talk about n for just a second. Remember, n is where I'm at in the sequence, the number I'm at in the sequence. So you guys stay on page 9, but I'm going to flip back to page 8 for just a second. Here I have a sequence. This would be the first term in the sequence, the second term in the sequence, the third term in the sequence, the fourth term in the sequence, the fifth term in the sequence. I could keep going. Do I have a 2 2/3 term in the sequence? Over a 4.5 term in the sequence? Is that something that seems reasonable or makes sense? What's term 1.5? Here's term 1, here's term 2. Do I have a 1.5 term? No, right? Could I have a 4 2/3 term? No, I've got term 4, I've got term 5, there's nothing in between. Do I have a -7th term? No, I have a term that I start with and we continue. So when we think about what number a term can be, what this n stands for, what number a term can be, what values make sense and what values don't? What kind of numbers could I see here? Whole numbers? N should be whole numbers. And there's one other stipulation I want to put on that. So no fractions or decimals, and what else do I not want? Negative numbers. we're referring to something's place in the sequence. So we don't want fractions or decimals, we don't want negatives. Questions for me so far? Okay, so let's practice then identifying the type of sequence we have. So that will be review, and then writing these new formulas. So for A, I've got 30, 40, 50, 60, 70. What are we doing here? We're adding 10 each time. Arithmetic, geometric, neither. Arithmetic, we're adding, it's arithmetic. And so if I want to write a recursive formula for this, recursive meaning it's based on the term before it, for whatever term I want, that's a sub n, I need to take the previous term, that's a sub n minus 1, and I need to add 10. So take the last term and add 10 to get the next term. Questions on A? Okay, let's take a look at B. 80, 40, 20, 10, 5. What am I doing here? Multiplying by 1/2, very good. What type of sequence would this be? Geometric, very good. And so our recursive formula would look like a sub n equals a sub n minus 1 times 1/2. To get the next term, I take the last term and multiply it by 1/2. How about C? 1, 2, 4, 8 times 2. So what kind of sequence is this? Geometric, very good. So this would be a sub n equals 2 times a sub n minus 1. One, 1/2, 1/4, 1/8, 1/16. What am I doing there? I've got 1, then 1/2, then 1/4. Yeah, I'm cutting it in half. I'm multiplying by 1/2. So this would be what kind of sequence? Geometric. And my recursive formula would be a sub n equals 1/2 times a sub n minus 1. What about E? What? Arithmetic. What am I doing each time? Yeah, we're subtracting 7 each time. So our recursive formula would be a sub n equals a sub n minus 1 minus 7. And our last example on this page, 1, 3, 7, 15. What are we doing there? How could I get from 1 to 3? Add 2. From 3 to 7? Add 4. from 7 to 15 at 8? What type of sequence would this be? Arithmetic, geometric, or neither? Neither. For arithmetic, I have to be adding the same thing every time. So this is neither. Now, on a quiz or a test, I'm not going to ask you to give me the formula right now for something that's neither just arithmetic or geometric. But one way I could describe this is that to find a term, I can take 2 times the previous term and add 1. That would work to describe this. So 2 times 1 plus 1 would give me 3. 2 times 3 plus 1 would give me 7. 2 times 7 plus 1 would give me 15. There are potentially other ways that you could describe this. And again, for something that's neither, I'm not going to ask you to give me that formula right now, just arithmetic and geometric sequences like we did at the top, but I wanted to show you an example of what those recursive formulas could look like. Questions for me on page 10? Okay, let's take a look at just a couple more together. So on the next page, page 11, the bottom, number 2, looks like what we just did. So I want to take a look at a couple problems on the top. This time, you're given that recursive formula and one of the terms. I want you to tell me the type, which you did before, and then you're going to fill in that sequence for me. So remember our notation here, a sub 1 means the first term in the sequence is 7. So my sequence starts with 7. And then my recursive formula is telling me to find the next term, take 3 times the last term, so 3 times 7, that's 21, and then subtract 3. So 21 minus 3 would be 18. To find that next term, I would take 3 times 18 and subtract 3, and I would continue that. So based on our formula here, arithmetic, geometric, or neither? Neither, yeah. If I were just multiplying, this would be geometric. If I were just subtracting, it would be arithmetic. Since I'm not doing a single of those, this would be neither. So take a minute and fill in the rest of this sequence and try B. For A, after 18, we should have 51, 150, and 447. And then for B, our first term is 2. And then our formula, or our equation, says take the previous term and subtract 7. So 2 minus 7 would be -5, then -12, then -19, then -26. What type of sequence would this be? Arithmetic, good. So your homework for today is to finish page 11 for, yes. Do you have a question on this? Okay, what's your question on D? So because of the N? Okay, so this says our first term is 1. And now this is telling me for whatever term you want to know, take the spot that that term is in. So if you wanted to know D sub 2, this would be 2 times the previous term. So right here would be 2 times 1, which is 2. For the third term, it would be 3 times 2. Does that make sense? Yeah, yep. Other questions on our material for today? Okay, so page 11 is your homework for today. For the rest of the week, we will not be on Zoom because we're going to do some more practice with these recursive formulas, and I want to be able to talk to you guys and check your work, and that is difficult to do when we're half in person and half on Zoom, okay? So no Zoom for the rest of the week. Instead, on your remote day, I want you to work on the 2 problems on page 12. So you guys are remote tomorrow, no Zoom, you'll work on page 12. You guys who are on Zoom today, I'll see you in class tomorrow. So we're going to do some more recursive practice and you'll work on page 12 on Friday.